Okay, hello fellow code monkeys. Welcome back to the show where we make stuff happen. So today we'll keep going. We're gonna keep going with the random sprite generation. Oh, that was not supposed to happen. Does that show up on the stream? Yeah, it does. Oopsie, that wasn't intentional. I actually don't even know what I did. I guess there must be a keyboard shortcut for locking the computer, and I accidentally hit it. I was just gonna open Lunar Magic, guys. Just gonna open Lunar Magic. Alright, so this is our level. This is our code file. We actually have two code files because we also have a simple projectile sprite. Today I'm hoping that we can get that we can set up some chunks that we can reasonably use to generate like level stuff that looks like it should be in a level. So we're going to remove all of these. And we're gonna keep working on this like generate chunk code here for generating terrain. So what do we have? We have this thing, we have test chunk. Let's bump this up all the way here. And let's just see if this chunk works, because we didn't completely test it, right? Oh, come on. Are we gonna get anything? We are going to get something. So it doesn't perfectly work. There is something missing here. And let's see, what are we generating? We're generating we're trying to generate a coin, a berry, and a block. And we're not getting the coin. I don't know why we're not getting the coin. So we go here in the world and then generate, the pointer is stored there to 4. So we do this, see if it's all good. It's all on screen, and it is. And then here we read the pointer, we read the header, then we increment it past the header. We get the index, whatever, EC mode. We do this, load 0, y equal to 0, then we compare it to 6. If it's greater, we go to done. That's clearly not happening, so we are in fact doing this. We are writing something to map 16. Could it be that 2A is one of the fake coin tiles? 2A. Yes, invisible coin that only becomes visible when Mario hits blue POW. Okay, so that's why the coin didn't show up. So let's add a POW here and see if it actually works. This is now the only way to test if coin is real, this chunk is real. 2021. Let's press it. Oh, we could barely see it, but yeah, it definitely works. Check it. Check it, baby. There we go. Chunk is real, 2021. Okay, so we're definitely generating chunks now. So this format is going to work. This code is greenlit. It's definitely doing what it should do. Now, what we actually need to do to make this work is we either need to make sure, so we need to mirror this. Remember what we said about, let's get these back so it's easier to show. So the reason we set it up with 4 screens like this is so we can mirror it. So whenever we write anything here, we also put it here. Whenever we put something here, we also put it here. So 0 and 2 should be perfect mirrors of each other. 1 and 3 should be perfect mirrors of each other. And that's very important. So what we can do is we can add an automatic mirror inside the generate chunk code here to check whenever we're writing to screen 0, we also write to screen 2, and so on and so on. Or we can make sure that we call this twice. I think it might actually be better to call this twice. Maybe? So what we can do is... no, that's definitely not going to be the case. So let's see. What we want to do here is right here where we write the map 16 tile, right? We want to check which screen we're on. And we do this most easily by just... what is the easiest way to do that? I don't even know. Let's... I guess we add something here. We're going to add height times 2. Good, all good. 13D7 address ASL store to A, height times 2, and we can use this. So let's see, if index is greater than height, we're at least on this screen. If it's greater than height times 2, we're at least on this screen, right? So what we do here, so here's where we're gonna write the second tile. CPX BCC loop. So we're gonna need to push X here. Push and pull. There might be more. Oh, right. We also have to account for. We're gonna have to restructure this quite a bit because we are currently not accounting for screen borders at all, and we do need to account for that. But for now, what we're going to do is compare to A, BCC, low to high. So if it's less than this, it means it's on screen 0 and 1, and it's in this area. And we're going to mirror to this area. Oh, here. Otherwise, it's high to low. Right, we also need to, here, we need to also push and pull A. This is looking a little messy and it's not super efficient, but we're probably not going to be generating a lot of chunks on any single frame, so I think this is probably okay. I really don't see this being very problematic. High to low, no, actually we're subtracting. Tags. Let's actually just draw right mirror, I guess we can call it. Here. Oh, I guess we have to do that. Tags. TXA. I guess we can put the TXA here. Very slight optimization. CLC, ADC. That's the only difference there. Oh, hi. There we go. Tags, pull A. Yeah, and then we just copy this actually. And we pull X, of course. So this is our, should we block comment this? I don't think so. We don't block comment on this show, we don't. Is this a show now? Am I gonna call this a show? No way. We don't block comment on this channel. Okay, so I'm pretty happy with this part. This part, I'm gonna have to change something major inside the loop, I think. Where is even the loop? Here's the loop. So this should all be pulled together, like so. Okay, what I'm not happy about is the way we're doing... I think I need to set this up so we actually assemble a new coordinate every loop. I think that's how we're gonna have to set it up, because it's just so doing this is never going to account for a screen border. For example, like let's say I wanted to add like 8 to this number and we're like spawning it here. We add 8 to x coordinate, but because of how the index works, we go 8 steps to the right. So 1, 2, 3, and now we're here. 4, 5, 6, 7, 8. So we end up here. We started here, we would expect to end up like here, but instead we end up here, like one tile down. That's not what we want. We definitely want the chunks to be able to cross screen borders. Although, we do have to be very careful about this screen border here. And I think what we do to circumvent, okay, so we don't want to cross this border, right? If something crosses here into screen 4, we actually want that to go on screen 2, right? The only way to cross into screen 4 is if we try to generate something on screen 3 and it crosses over to 4, but because the mirror goes like this, we would like it to go to screen 2. It could also go to screen 0, that doesn't really matter. So I guess we're gonna aim for 0 because that's easier. It's gonna look simpler. So we're actually gonna do this. Height times 2 and height times 4. That's how we're doing it. That's how we do it, baby. Here. And we're gonna make use of that. And on all of these, this is gonna be a bit more difficult on this one, I guess. On this one in particular. Plus 8. So 8 is the index. Here we compare to C, BCC, whatever. If it stays here, the carry is set, so we just SBC C, I guess. This one we're gonna add a comment for. Make sure to not go to screen 4 plus. Wrap 3 to 0. And then we also need to add that here before the tags. Right before the tags. So now we have accounted for that. That's very good. We're still not accounting for this. Like 0 to 1, 1 to 2, 2 to 3. We're still not accounting for that. I guess we don't really have to account for 1 to... this is the only one that's gonna need an exception. For the rest of them, we just want a loop that takes care of it. Because just think about it. So we're on this part, right? We're generating something here. It wraps over to 2. It's fine if it ends up in 2 because it's going to get mirrored to 0 anyway, right? And that's why 3 wraps to 0 because it gets mirrored to 2 anyway. Because the mirror is based on a block by block thing, block by block basis, whatever. I think we're going to move these to C and E. Let's see, E, E, C, C, E, E. There we go. And C. Like so. And then we want to do this. And this is going to be X low nibble of index to map 16 table lowest actually. Highest 3 nibbles of index to map 16 table. That's how we're gonna split it. So where are we writing to 8? Here. That's where we're writing to 8. So LSR here, we're just gonna put that in. This makes more sense, doesn't it? Low first, high after. So here, where did we go? Here, LSR, write that there. Lowest nibble of index. Yeah. And then we just store this to A. And then here we add this to A, like so. So now the way we're gonna do it is that highest 3 nibbles of index. And of course a nibble is just a hexadecimal digit. A 16-bit number is 4 digits, so this is 1 digit here and 3 digits here. We add them together, we get our full 16-bit index. Even though the index only goes up to 3,800 minus 1, of course, like so. But we are still using all these numbers. So here is where we go for figuring this out. So now we are able to do this. We actually don't. We have the base indexes already, right? We don't need 0 and 2 anymore. We don't need them. So we can actually use those as scratch. And we're going to do that. 0. Like so. Here we go. We add this here, we add this number. No, we can't do this quite yet. We have to do it in the opposite order. We have to do y first. This is gonna make sense in a second, okay? So here we get the y value, the y offset, which just doesn't include those, it's just 1 digit. We get that there. We add this, right? We add the offset from the y position. Stored in 2. Boom. Then we take the x offset here. This is just lowest nibble here. We add the x position of the index. But here we have to check. Did this make it change screens? Same screen if it's less than 10. Because 10 in hex is 16. So it's less than 16, we're still on the same screen. Wonderful. Keep going. Actually, don't store to 0, just fucking aura 2. Like so. Current, the index for current block. Actually, a equal to. It's getting a little bit important to have some comments here so we know what we're doing. And here, if we did go to the next screen, we have to remember this number here. And then we take this number here and we add the screen height. There, load 0 back. And yes, storing to DP is faster than push and pull, so we're storing. I'm referencing this a lot. Maybe I should just give it a define name. Well, at this point we're done with it. We're not going to use it anymore. So let's see, is this actually the loop? I don't think this is gonna fit in one loop. This is a lot of code. It's gonna be like 140 minus. No, it's not. It actually works. I guess because we're using mostly DP. So, does it generate properly? Does it generate at all? It's generating here. That's for sure. So it doesn't. Oh, time up. Time up. Whoa, something is going very wrong here. This isn't what's supposed to happen. Why did it say time up though? Oh, can you jump up there? Is it too high for little Mario's stumpy legs? Come on, little Mario boy. Get up there. Can he really not get up there? No, he can't. There's an invisible thing here. Can't get up. What is it? What happened? Okay, so something went not good. There's really no way to get up there. That looks so strange. It really like messes with my brain that this invisible block is solid. So, what did we do wrong here? Let's review our code again. So we're getting these offsets. This might be the first time we step into the debugger. So we're getting this here. These offsets. Adding a. That's right. We set that there. We're adding this x offset to 8, and we did set 8 here, so that's right. We're checking if we're still on the same screen, which we should be most of the time when we're doing this. Same screen, we go here. Or at this, whatever. Compare, subtract, tax. Okay, so we do that. That looks right to me. What about this if it's a new screen? So we AND this to remove this excess bit here, so we're still only having the X bit here, or the X nibble. Store it here. Then we get this. Actually, what we can do is, it's BCC, right? So we can do ADC here. ADC is free. Doesn't cost a CLC this time. So we do is, we still keep that, but we do... we just, honestly, we can just ADC this. We ADC this as well, then we ADC this. Except carry here is not clear, so we have to do this. Carry is never going to be set by this operation. If that's the case, then this is just set incorrectly by Lunar Magic. I don't think that would be happening, so we're just going to do ADC here. We're probably getting the right index. I really think we are. And this should never fail either. It's if we are greater than E, we subtract E. That should never result in a negative number. And then we put the index in X, of course. We get ready to read the next byte, or the next word as it is, 2 bytes. So read the block number. We push X here, because we're going to override it. I guess we should really be pushing it here. Yeah, to me that makes more sense. I think reading this is probably faster than push-pull X, or push-pull A. I'm gonna look it up real quick. PHA costs 3 cycles. Is it only 3 cycles? It should be more than that. PLA is 4 cycles. Like it's a 7 total. LDA, DP, Y is 5 cycles. Is that right? Yeah. Okay. So it's definitely faster. So let's get rid of this push A, get rid of this pull A, and instead we just read this again. We store this here, store the high byte here. Yeah, of course it failed. Of course it generated garbage. We flipped these. We flipped the bytes. We stored the high to low and low to high because we just pushed and pull after doing the XBA thing. All right, it should work now. I mean, a lot of the time, like you look through your code and you think there's gonna be like a bunch of huge errors, and there's just this one simple silly thing that went wrong, and it's like messing everything up. Is this working? Do we still have invisible blocks? We do not. Because here, obviously, you can't see the block because it's spawned inside another identical block. Okay, so we're going to add some RNG to this thing. Isn't that exciting? So, I don't really know what we're gonna do with the RNG. I think the default RNG is not very good. It seems like it tends to be very predictable. So we're probably gonna do something of our own. So for now, let's put it in debug or in debug. Level loop code is what we'll call this. We'll call this RNG code, random number generation code. And we'll get a thing, a value, probably a free address. I don't know if we can get those. We probably can. What should we use? Let's add one that we call let's put it at the top. Free RAM. We call this one RNG, just RNG. Let's put it in, I think this one is free, like by default, right? So we're gonna use this for now, and then when we actually port this to the project, we will make sure to update this to something that's actually free, because this one is probably taken. This one is almost always taken first because it's so convenient to use. What we'll do here is we'll just, we're not gonna initialize this at all. We want it to be random. We really don't care if it gets destroyed by anything. RNG. Random, like so. Just get a random number, 0 through the previous RNG. And let's just add a bunch of things to it, I guess. Let's try that. Let's try adding, let's add Mario's control registers. Let's add, what do we add more? Let's look in the RAM map. What's something that could be fun to add that might make this unpredictable? We can add, actually, what if we made like an RNG table? We generated a bunch of these. That could be helpful, actually. Let's add Mario's power-up status, why not? Let's add... Has to be something that tends to change a lot. Let's add Mario's positions. 94, 95, 96, 97. Let's add his speeds. This is a mess, isn't it? Actually, this is looking pretty expensive already. I don't think we want too many of these every frame, but maybe we don't need to do it every frame. Let's see there. Are we actually ever using the high bytes? No, we aren't. So let's do that. Let's also add. Let's add all of these that we're using. Like this. Y low and Y high. Let's add speeds. I don't really know what's going to happen here. I'm guessing we're gonna get something weird, but that's the point. Let's add right, Mario's block status. That's 77, isn't it? It is. Blocked. What's the cost of this routine? It's a little expensive, but it's gonna be used a lot. Or the result is going to be used a lot, so I think it might be fine. Let's add some subpixels. Everyone loves subpixels. Fraction bits is what those are called in the RAM map. 7A. And do we have something for Mario Y subpixel? Here, 13 DC. Huh? Accumulating fraction bits. Fractions of 16 bits 4 through 7 use 12 bits 0 through 3 are always 0. Alright, let's use those instead then. 13DA, 13DC. Yeah. Then let's add the sprites fraction bits as well. ASM, SA1def, frac, sprite speed Y fraction, sure. Oh, don't want that. And X as well. RNG. Let's just do that. And let's see if this is as chaotic as I hope. Oh, did we mess up? No, it seems like we're still live. At least I hope we are. I accidentally closed the YouTube tab I had open for the stream, but it seems like we're still good. We're still good. Awesome. So let's see. From now on, we're not going to be using this. Maybe to make sure this actually. We don't want this to be too predictable, right? But we might want to make use of this one more time in here. Let's put it here. Random. And maybe this will eat some like player control or whatever. I don't know if this is actually... So here... RNG. So let's read this value instead. One weakness with this is that we can only really generate numbers that are multiples of 2. But I don't think that's going to be a problem here. Random. What else do we have? Up to 20, huh? RNG. We just do that. Haha. Okay. Make. No, not yet. Terrain. No. Interaction. We need for terrain generation. Yeah, we already know that. We already know these. So here, we're gonna start by adding some randomness here, I guess. Store that there, whatever. RNG. And let's just add, let's start at CO and add a random number, I guess. Or we just add this value. We add like so. Make. Let's go. Let's see if this actually goes into random heights now. Now that I think about it, maybe it was actually completely pointless to make sure the chunk can generate like things on the sides, because we're probably only gonna want to generate column by column. Oh hey, look at this, that looks awesome. Oh, we got two of them on the same column. Oh right, we're looping now. So we're gonna keep like breaking this level with our random terrain generation. Not that there was much level to break in the first place. Okay, okay, we're getting somewhere. We're getting somewhere. So, but we might actually, we still might want some. So we're probably gonna generate chunk by chunk. I think we'll get rid of this at this point. We're going to generate chunk by chunk, but column by column, but we still want to be able to like generate stuff on the side. Mostly to make sure the map 16 can look nice. Let's see. Whoa! Did we really just make this? Also, it seems like it's not quite working. This isn't supposed to happen. Oh no. Oh no. Where do I go? Oh, this is funny. What in the world just happened? Why doesn't it want to go further down? Is all this real terrain? It didn't seem like it before. Can it actually generate stuff inside? Can it generate stuff inside the tile map zip? Okay, I don't know why it doesn't go further down. Oh, it's because I'm only adding up to 127 pixels, right? Yeah. So, what can we do about that? Let's add E, see what happens. It's just gonna go further down, we know what will happen. So, this wasn't supposed to happen. Also, this was a bit too often. 3, E and E plus, whatever. Okay, so there were some things going wrong. There were some blocks I could go through. You're a little drowsy. So let's see if we can encounter some of those again. We're not getting a big old disaster blob here. How come? And 03. Oh shit. That was a mistake. That was a blunder. Let's go here. Let's see what we get. Okay, I don't. Okay, there. No. That was definitely a tile I could walk through. There are some tiles up here that are not solid. I wonder why they're not solid. So that means they are... why would they not be solid is what I'm wondering. It could be that there are berries generated there while the tiles are on screen. It could be that they are... yeah, I guess that's the only like guess I have. But like, why are there cement tiles there then? I'm guessing the mirroring doesn't really work. That's my only guess right now. You can see that we are generating a bunch of stuff. Whatever. I don't really know how to design these chunks to make them like make this fun to play, but we'll figure that out. We'll figure that out for sure. For now, we want to actually solve this bug as well. Oh, maybe I should brew some tea. I'll be back in a minute. Just gonna go put on some water so I can make some tea. Alright, let's go, fellas. Let's go. So, what can we do about this? I think this is probably gonna be the worst part of the stream. Like, I'm a little bit stuck, don't really know what to do. And I'm also like too tired to figure it out quickly. Oh boy. So, I think the next step is to open this into the debugger and see if we can figure out why some of these tiles are not properly interacting with us. So we're gonna open the timeline viewer, auto update, refresh it, whatever. Go here. So we have this, of course we do, and let's blast this up a bit. Okay. So we're adding a lot to the X position here. So when we're here, we're actually generating here. Oh, I see. Because we're doing +2. We're doing +2, right? So if we're here, the camera is here, right? I just figured it out. So the camera is here. That means we're generating here on this column, which means that it's actually going to show up here. That's not good. That's not gonna work. We need to be able to generate stuff here. Or, well, in this area, right? So adding 100 isn't gonna work. As we can see here, let's go back a bit to here. This is how wild the zip is. How wide the zip is. So we go all the way here. So this is what we see on the initial zip. How big is that? It's 20 tiles. Anything past that, if we write to this column, that's fine. That's all dandy. So I think we're going to add exactly this amount, right? Because we know for sure this is the width of the zip. It's never gonna be bigger than this. So if we just add 20, that's probably fine. This is 0, this is 20. So let's just change our +200 to +1AO. Like so. That should make sure we don't get any fake tiles or fail tiles or whatever. Let's jump around a bit to see if we bump into anything. And this already seems a lot better. Seems to actually interact like it should. Okay, and with that, I dare say that the chunk loader is in fact working. We are randomly generating terrain that interacts properly, loads properly, the level loops properly. Now we get into the design part of this thing, which is that we are gonna have to design the chunks in a way that makes for a fun level. And we don't actually want this to be very complicated. I'm going to bring up the like boss that inspired this. Let's see if we can get it. It's Kirby Nightmare in Dreamland Boss 5. I have no idea what this guy's name is. Kirby Nightmare in Dreamland, all bosses no damage. No, that's Heavy Mole is his name apparently. So it's this guy. No, YouTube, don't do that. You ever seen this before? So, okay, yeah. Now that I review it, there isn't actually any randomized terrain here, right? The boss is just digging through a solid chunk, but this was what inspired it. That you get this sort of like level that gets built on the go, sort of. And you just deal with it. But we're not making a boss like this, like we're gonna interact with our boss, but... and the boss can sort of destroy terrain as well, that's pretty fun. So let's get rid of that. And let's figure out how to do that. How to make for a fun level. So first things first, we're gonna need some better chunks. This test chunk, pretty terrible. We're going to start with this as our core chunk. I guess we can also do this. This is gonna be the format of our chunks from now on. We're gonna call this single block. Let's see, end, start. That's not a single block though. What do we call these? I don't know what to name them. Oh right, also I figured something out. We also have to check here in generate chunk. We have to make sure that when we apply this here, where is it? Here. When we get the vertical offset, we are not 13D7, right? We're not bypassing this. I said we were done with this address finally, but it seems like we're not. We're always gonna use more of this. If we're going... wait a minute, this doesn't work either. Damn it! How do we know if we How do we know if we crossed this line here? I guess we don't actually need to know that, right? Because if we do, it's just gonna appear here at the top of the screen, and that doesn't actually make a difference. Yeah, the player can never tell that that happens. So, sure, let's not worry about this for now. Let's just not worry about it. It doesn't matter. It doesn't exist. That's not a problem for us. Let's call this... So, like, I don't really know which chunks we need to make, because we don't have any map 16 to work off of right now. Maybe we should make some... We'll make some, like, basic chunks for now, and then I'll go ask for, like, the map 16 to work with, like, maybe for tomorrow or something. Single block, big block, and this is just gonna be, like so, like a 32 by 32 block. And then we'll also have column damn it, so used to double tap. A column that's going to be let's do 4 of these. Let's just do all the Tetris blocks. why not? Let's do all the Tetris blocks. No, that's terrible. Why would we do that? Let's make a row as well. We're just gonna do the same thing as this, except the progression is going to be like so. Okay, and then let's do a table here, chunk table, single block, big block, column, and row. And then here, we're not just gonna randomize this position, we are going to... actually I just got an idea. What if, instead of actually randomizing the terrain, we just have a solid terrain and we randomize a path through it? What if we did that instead? That would actually be pretty sick, wouldn't it? Because I was thinking right now that we need to keep track of what we generate so that we don't... It's like maybe we have like a path that goes like this and we like randomly like distort it up and down or whatever. But we don't want to like distort it too much so that there's no path for the player to go. Like we definitely want the player to be... Like we never want a situation where the player just is forced to die because the terrain doesn't let them progress. We don't want that, so... Okay, it sounds like my tea is finished. I'm gonna go get it. And back we are. So I was foolishly thinking we would get done with this like terrain generation today, but I guess that's not the case. So maybe my original estimate of like 5 episodes to make any real progress is was actually quite appropriate. Anyway, so we're gonna change this thing here. Instead of passing test chunk, we're going to read from this pointer table here, chunk table. Let's get RNG 3 ASLA tie. We don't need to specify .w because y can only read in this bank anyway. Test, no, not test. That was the word I was supposed to remove, right? Test table, like so. So we're doing that. This is clearly still way too much. It's gonna generate way too much stuff. But let's bump this down to 7, I guess. And then let's also put this to, I don't know, further down somewhere. Put it to 100, see what happens. What's the worst that can happen? Okay, that's pretty bad. Immediately, that's pretty terrible. Okay, this is what we have made. It's absolutely awful. And the worst thing about it is that this is permanent. Whenever something is generated, it's gonna stay here for every loop, right? So we probably want to clear stuff like right behind our screen, right? Even if it doesn't update on the time map immediately, that's fine, doesn't matter. We're gonna add a special chunk. We're gonna put this above the table just to show how special it is. Cleaner chunk. Hello, Lightvein. Welcome to the stream. So, if you're wondering, today we are working on terrain generation in real time. It's gonna be heavily featured in the first phase of the boss. It's currently a mess, but we're getting there. Just putting all the technicals in place, and we'll worry about the design later. So this chunk is just gonna be a column of air that we'll just place it like every frame behind the camera to make sure that to clean up all the like stupid shit we generate here, right? So to make sure we don't generate any like kill boxes or anything. Yeah, progress is going well actually. I was surprised by how much fun it is to stream this. I was worrying that I would have too much stuff to do these days since school is kicking off and everything, but it seems that I thrive when I have more things to do than less things, which is great for me. So let's just bump this up a lot. 5, 6, 7, 8, 9, A. Let's do... We don't want to do too much because it can cause lag. Remember, we're not on SA1, so we do actually have to worry about stuff like that. But we're gonna do this as a test run. The cleaner chunk. So how often do we need to do that? Let's see, we move, how far does the camera move every frame? It moves half a pixel every frame. So we only need to do this once every 128 frames. Like so. We're also going to bump that down there to make sure it's never skipped. And we are going to go into 16-bit A. Does this end with SEP30? It does. Very good. No, we don't want RNG. We want cleaner chunk. Let's read 4. And then we want, what was the height we wanted again? Was it CO? Wait, CO is here. No, damn it, here. And we go all the way down to 26, right? That's too much. Yeah, okay, so we can actually kill 2 of these right away, which is very good. The more of those we can get rid of, the better, actually. We might have to split this into several chunks and load like one every frame to make sure that we don't like do too much on one frame and get lag. But we still want it on CO, I believe. And then we want 1A and just -10, put that there. Generate chunk. And now whatever shows up in our thing here should only persist for one loop. Let's see if it actually does that. So, okay, we're generating a bunch of garbage here. That's great. That's exactly what we want. And let's see if it persists or... Oh no, the boss died. Damn it! Is it gonna stop now? I have no idea what will happen now. So the only stuff that should persist is are the blocks that go behind or go below the ground. Did I make a mistake here? 16 times 2. 16 times 2, not 16 times 8? What am I thinking? Of course. Okay, now, let's test it again. We might still have the wrong y-coordinate there. Yeah, we definitely have the wrong y-coordinate there. So it seems like we're generating a bunch of stuff in front of us. That's very strange. I don't know why that is happening. I don't know why that is happening. Oh. Aren't we doing... Yeah, we're definitely subtracting. So why is this cleaner chunk going in the front? So here... For this one, oh, this is a problem, isn't it? So this can happen when it goes to 0. Also, it's still one too tall. let's get rid of this. And let's make sure we actually generate it in the right place. CO, generate chunk. Minus 10 is, so what is the problem here? I guess we'll just do this like BPL, just clamp it to 0, it has to be a positive number. That's a good start, right? So this seems a lot cleaner, which it should be because we have the cleaner chunk. Oh, if we don't have it, we should eventually run into a completely solid block of like gray matter here. Gray matter, like this is a big old brain. But that doesn't seem to be happening, so I actually think we are in fact getting the cleaner chunk to go off. Although there's definitely an easier way of checking for that, I guess. By just placing a bunch of stuff in Lunar Magic. But yeah, the cleaner chunk is definitely going off. Like, this is changing like every loop. Like, this is changing a lot every loop. Yeah. So that's good. That's good. Now, I guess what we need to think about is how to generate terrain that is actually, you know, suitable for the boss fight. I really don't know how we're gonna do that. And I'm really tired right now, so I think we're gonna take a break here. We didn't make a lot of progress today. We did improve this and get it to a point where it works. We added the cleaner chunk, which is definitely going to be, well, it's gonna be super important later on. Actually, something we can do right now is split the cleaner chunk into several parts. So how many frames are there in between them? There are 32 frames actually, so we can load one cleaner chunk every frame. That would be ideal, I think. Total cycle cost is higher, but it's gonna be a lot more even, and that's very valuable. So let's just this is gonna be the last thing we do today. Cleaner chunk, no, cleaner table, cleaner chunk 0. How many tiles do we have? 14? 13. Yeah, so 2, 3, 4, 5, 6, 7, 8, 9, A, B, C is what we have, right? But then how do we and we have a few, let's see, D, E, F that are not gonna be used, right? Do we spread these out? I guess we spread these out. Yeah, just spread them out a bit more, I guess. 4, 3, 4, 6. That's not good. I guess that should be the last one then. 5, 5, 3. So I guess 5, 4, 4. That's good. Cleaner chunk, and there's gonna be a lot of repeats here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. And now let's make sure we name them all. I know this is very ugly. We're just gonna make this once, then we don't have to look at it ever again, I think. At least I hope so, right? 9, A, B, C. And then we make sure these offsets are correct as well. B, A, 9, 8, 7, damn it, 6, 5, 4, 3, 2, 1, like so. And then here we do this. This is gonna be pretty smart, pretty smart. It's gonna be pretty smart. Right, I guess this is just 16. When we need, no, we just skip every other frame. So we do this. We get do we even do that? No. We don't need 16-bit X. This is ridiculous. So we load this. We get let's start by doing this. LSRA, BCS, I guess, plus we only do it on even frames, so we ASLA. That also clears the lowest bit, which is perfect. Then we AND 1F, and this is actually the same as 1E, but whatever. Tax, let's do type, that's what we're doing for the other ones. Also means we don't need to specify .w here. Cleaner table, like so. And now we spread this out over 16 frames instead of doing it all every frame. Assembles, it should work, it did not work just fine, it didn't work at all. I don't know why that failed. Right, of course. I forgot to code in this exception. I even wrote it in the table and I forgot to code it in. That's really smart of me, isn't it? So we are in fact going to need this here. Here. BQ plus, and now we go again. And we should be all golden. We should be golden, baby. The cleaner chunks do seem like they are in effect. Like this pattern doesn't quite repeat. See, this is a different pattern here. We are getting different patterns. And we're not getting completely filled up. Yeah, this is a different pattern from last loop for sure. Yeah, this looks very different, so that's great. That's great. Let's go. Okay, cool stuff. Cool stuff. So, we did split our cleaner chunk and we fixed our generate chunk code. It should now work with mirroring, with looping, everything. So next episode, we're actually gonna figure out how to do this, how to design this, how to design the chunks to make sure that this terrain becomes playable and stuff. For now, we solved a lot of technical issues. We also kind of future-proofed this, which is great. But that's gonna be it for today. Stay hydrated, fellas, and always slurp your tea when you drink it. That's way nicer. And, well, see you tomorrow.